In this video, we are going to discuss about the introduction to biomedical sensors and measurement systems. So by the end of this topic, students will be able to understand biomedical sensors and measurement system. They can able to explain different methods of measurement. They can able to classify the instruments, and also they can describe the functional units or elements of the generalized measurement system. So what is a measurement system? Measurement is a process that is used for determining the properties or magnitude of an object by comparing it with the standard quantity. So this is an important technique actually used for expressing the physical quantities such as length, pressure, temperature or time. Here the measurement plays a major role in science, engineering, healthcare and biomedical applications because accurate measurement helps in proper monitoring and diagnosis. Instrumentation is nothing but it refers to the devices and system used for measurement and control purposes. This measurement system is actually a combination of devices, methods, procedures for measuring the physical quantities. So here it helps us to understand the characteristics and behavior of each object's systems or processes. These measurement systems are widely used in many fields like science, engineering, manufacturing and healthcare. In biomedical engineering, these measurement systems are used for monitoring the physiological parameters like ECG, blood pressure, temperature and oxygen saturation. These measurement methods are broadly classified into two categories. One is direct methods, another one is indirect methods. These methods are selected depending on the nature of quantity, where we are measuring it and how the accuracy is required. And in the direct methods, the unknown quantity which we call it as measurand is directly compared with the standard value. So this result is expressed in numerical form along with that unit. Direct methods are commonly used for measuring physical quantities such as length, mass, time, and the examples of the instruments used for this direct measurements are vernier calipers, micrometers and even coordinate measuring machines also. For example, if the length of a bar can be measured directly using a measuring element, however, direct methods may not always provide very high accuracy because of human errors and practical limitation. So we go for the indirect methods. So indirect methods are used when direct method is not possible or practical. In these methods, quantity is measured indirectly using another related parameter. For example, pressure gauge type level measurement, differential pressure measurement, ultrasonic measurement systems. In indirect methods, it is widely used in engineering and biomedical applications because many physiological quantities cannot be measured directly. So instruments are mainly classified into two categories. One is absolute instruments, second one is secondary instruments. This classification is based on the method used to determine the measured quantity. So first one is absolute measurements. So absolute instruments measure the quantity directly in terms of physical constants of the instrument. This instrument does not require any calibration with another instrument. Example, tangent galvanometer, Rayleigh current balance. Absolute instruments are mainly used in standard laboratories and research institutions because they provide high accurate measurements. In the case of secondary instruments, this indicates the value of the quantity directly through their output. So these instruments require calibration using absolute instruments or already calibrated secondary instruments. Secondary instruments are commonly used in daily measurement because they are very simple and convenient. Like examples, voltmeter, glass thermometer, pressure gauge. So this most biomedical instruments will be used in the hospitals. And next is the elements of the generalized measurement system. It consists of three main functional elements. One is primary sensing element, variable conversion element, data presentation element. So each element will perform a specific function in converting that measured quantity into useful information. First we can see about the primary sensing element. So primary sensing element is the first component that comes with the contact with the sensor with the quantity being measured. So it detects the physical quantity or the measurement, and a transducer is commonly used in this stage. So this transducer will convert the physical quantity into electrical signal. For example, temperature, pressure or displacement that can be converted into electrical signal for further processing. Next is the variable conversion element. So variable conversion element is the output from the primary sensing element. Therefore, this signal is converted into suitable signal, that is from the primary sensing element it will be given to the next stage in a suitable form without losing any information. For example, if the output is in the form of the analog form and the next system will accept only the digital signals, means this will convert it into analog to digital converter. So this process will help the signals to be very compatible with the measurement system. Next is the variable manipulation element. So variable manipulation means changing the numerical value of the signal, that is amplification, attenuation, integration or differentiation. For example, an electronic amplifier is increasing in their magnitude of small voltage signal. This process we call it as signal conditioning. So this signal conditioning improves the quality and usability of the signal. Data transmission element. So when different parts of the measurement system are physically separated, this data must be transmitted from one stage to another. This function is actually performed by the data transmission element. For example, in spacecraft communication systems, audio telemetry is used to transmit the signals between the Earth and the spacecraft. In such case, biomedical systems, data transmission will help in monitoring, remote patient monitoring and wireless healthcare systems. So this will be given through the data presentation element. The final information must be displayed or recorded for monitoring and analysis purposes. So this function is performed by the data presentation element. For example, we can see this presentation in analog meters, digital displays, printers, computers, monitors. In biomedical systems, these devices will help the doctors to observe and analyze the patient conditions. So here we can see an example of Bourbon tube pressure gauge. So Bourbon tube pressure gauge is an example of a measurement system. In this system, Bourbon tube acts as a primary sensing element. This senses the pressure and this converts to the displacement. And the mechanical linkage will transmits the displacement. The gearing arrangement will amplify the movement. Finally, the pointer will displace the pressure value. So likewise, different functional elements will work together to perform the accurate measurement. And when pressure enters into the Bourbon gauge, so you can see here the pressure enters into the Bourbon tube and the tube is blending slightly. So this movement is transmitted through the mechanical linkage and the gears. And now the pointer then moves over this calibrated scale to indicate the pressure value. So this is actually the practical example of how measurement system converts a physical quantity to a readable information. So measurement systems are essential in biomedical instrumentation for accurate monitoring and diagnosis. So we studied different measurement methods, classification of instruments and functional units of a generalized measurement system. So understanding these concepts is important for designing and using the biomedical instrumentation more effectively. So here you can see the pointer is moving over the calibrated scale for indicating the pressure value. Thank you.